Okay, this time we're going to focus on this series and see if we can figure out whether it converges or diverges using the ratio test. Now, there are no factorials and no nth powers except for -1 to the n here, so it certainly seems like the alternating series test would work here, but we'll give the ratio test a shot to see what happens. So we'll look at the limit as n goes to infinity with the absolute value of an plus 1 over an. And here we have an is -1 to the n over n squared, and an plus 1 is -1 to the n plus 1 over n plus 1 squared. Okay, so we fill in the details here. This is the limit as n goes to infinity, the absolute value of -1 to the n over n plus 1 squared. Sorry, that's -1 to the n plus 1. That's an plus 1 over -1 to the n over n squared. Okay, that's equal to, I can ignore the absolute values and the -1 to the n, and so the absolute value makes the -1's go away, and so this is 1 over n plus 1 squared over 1 over n squared. And that's the limit as n goes to infinity. I invert this fraction and I get n squared over n plus 1 squared. Now the square function is continuous, so this is the limit. Putting it all together is a single square as n goes to infinity of n over n plus 1 squared, and because the square function is continuous, that's equal to a limit as n goes to infinity of n over n plus 1 squared. And now, of course, if I divide by n above and below here, I find that that's the limit as n goes to infinity of 1 over 1 plus 1 over n squared, and that's just equal to 1 squared. And now we know that that's 1, and the ratio test is inconclusive. However, we could settle this using the alternating series test. So we do have that the sum of -1 to the n over n squared, n going from 1 to infinity, is an alternating series, and we have the positive part, the absolute value of an is 1 over n squared, and we have that the limit as n goes to infinity, the absolute values, is the limit as n goes to infinity of 1 over n squared, which is 0, and we also have that the absolute values are decreasing. So we have the absolute value of an plus 1 is 1 over n plus 1 squared, and that is certainly less than 1 over n squared, because n plus 1 is bigger than n, therefore n plus 1 squared is bigger than n squared, and therefore 1 over n plus 1 is less than 1 over n squared. So we have the absolute values are decreasing, and so by the alternating series test, this series converges. And in actual fact, you could show that this series is absolutely convergent, because if I take the sum of the absolute values, I get a p-series here, 1 over n squared, which converges because p is bigger than 1. So, in fact, I have 2 ways to show that this thing converges. So the moral of the story here is that in cases where the ratio test is inconclusive, where you get a limit of 1, you have to try something else.